Welcome to Smart Dentistry YouTube channel. In this video, I am going to explain about the various processing techniques used for dental ceramics. It is one of the least understood or a complicated topic for all dental students. I have attempted to make it as easy as possible with a lot of self-explanatory images. If you are a dentist or a dental student watching this video, subscribe to my channel. I will be making videos that will be useful for dental students, emerging dentists, and clinicians. Although there are so many techniques by which dental ceramic restorations are made, these are the techniques which are currently used. Some of the techniques may be absolute nowadays. These techniques are also included here for academic reasons. The dental ceramic processing methods includes condensation, also popularly called as sintering technique, hard pressing technique, casting of ceramics, slip casting or infiltrated ceramic technique, CAD-CAM, that is computer aided designing, and computer aided machining, also mentioned as manufacturing or milling, then copy milling and machining, grinding of dry pressed ceramic powder on enlarged die. With all these 7 techniques, we will see one by one. Condensation technique. This is the most common technique used for metal ceramic restorations. This technique is also used for layering ceramics over the copings made by ceramics in case of all ceramic restorations used by many other techniques, which is mentioned later in this video. For this method, the commonly used Vita ceramic is an example. For this technique, ceramic is available in the form of powder and liquid. The liquid component is a distilled water or maybe a specialized liquid which is supplied by the manufacturer. The powder and liquid is mixed to a slurry consistency with the help of a glass or a plastic spatula. Using many techniques, this mix can be applied on the surface of the coping, but the most commonly used technique is to apply this mix with the help of a ceramic brush. The brush provides very easy and streak-free application of ceramics. Now the mix is ready to be applied on the prepared die. The ceramic restoration will be constructed over the die made from the impression obtained. This mix is applied over the metal or a ceramic coping made over the die. Sometimes ceramics can be applied directly over this die, but this is not a common practice except for making ceramic restorations on extremely non-stress bearing areas. The wet mix of ceramic is applied with the ceramic brush as required. All the ceramic powders will have a coloring agent in it. This gives specific color for the ceramic powder like enamel shade, dentin shade, etc. After completing one layer of buildup, it is fired for specific time and temperature in a ceramic furnace. The time and temperature varies depending on the material used. After firing procedure, it is allowed to cool. Once the ceramic is fired, it will lose the color added to it and will return to its original tooth shade as chosen by the dental technician. The procedure is repeated by adding different shades of ceramics to match the natural shade of the tooth selected. This procedure of adding layers is called as veneering of ceramics. Once the final shape, contour and shade is achieved, the finished product is fired again in furnace. Glaze, which gives a shine and resistant coating on the ceramic surface, is the last step performed after verification of the fit in die and if needed in patient's mouth itself. Some of you may be wondering how the ceramic sets once it is heated. For example, GIC undergoes a chemical reaction. Composite undergoes a polymerization reaction. What about ceramics? This process is called as sintering. Let's see with an example. as if you do not understand what is sintering. You may never understand about any of the processing techniques of ceramic. This forms the basis of all types of ceramic restorations. Let's imagine that we have taken some ceramic powder in a beaker. It is a free powder and it does not possess any shape or strength. Now we take this ceramic powder in a beaker and heating it at a high temperature. After that, it is allowed to cool to room temperature. Now, if you take the ceramic powder out of the beaker, it will retain the shape of the beaker. How this happen? Let's see that. These are two ceramic powder particles. Let's magnify it and see it in a closer look. Once the powder is heated, the surface of the powder particles melt and flows. But there will be no complete melting. This surface, once become molten, will adhere to the adjacent powder particle to form a strong bond. This procedure of adherence is called as sintering. So sintering makes the basis of condensation technique. It is also the basis of most of the other ceramic processing methods. So in short, ceramic powder is mixed with liquid and applied over the coping to attain the required shape and shade. It is then fired so that the powder particles undergo sintering to make a strong, naturally resembling restoration. It is then finished, polished, glazed and fixed in the prepared tooth. The second technique that we are going to see is hot pressing. Hot pressing is a commonly used technique to get high quality ceramic restorations. The called IPS impress is a hot pressing technique, also called as hot isostatically pressed glass ceramics. For this technique, the die is made from the patient's impression. Wax pattern of the coping is made with inlay wax and sprue is attached with the coping pattern. Wax pattern is attached to the sprue former. Note that the sprue former has a different shape in order to accommodate the ceramic blocks. The wax pattern is invested with a phosphate bonded investment. Sprue former, leveler and casting ring are removed and the investment is allowed to set completely. The wax pattern is dewaxed in a burnout furnace. The hot investment is loaded in a specialized hot ceramic pressing machine. The machine has a moving portion to press the molten ceramic blocks into the mold space created by the wax pattern. Two or more ceramic blocks are added and the investment is oriented along the plunger of the pressing machine. The machine is then activated. Once the specified temperature is obtained, the ceramic blocks will melt. At the same time, the pressing machine will press the molten material into the mold space. The investment is allowed to cool to room temperature. Divesting is done by careful sectioning of the investment and with help of sandblasting. Excessive force should be never applied. The coping is then tried in the die to check for the fit. The finished coping is then sent to the dentist to verify in the patient's mouth, that is in the prepared tooth. Once the coping is appropriate, then incremental layers of ceramic is added using the condensation technique to attain the proper shape, size and shade. This technique provides excellent fit for the restoration and gives a high strength. The third ceramic processing method is casting. Casting is a very common procedure for metal restorations. Ceramic casting can be done in almost a similar fashion that of lost wax technique, popularly called die-car, which is a name originated from Dentsply International and Corning Glass, uses a castable ceramic technique. Most of the steps are similar to that of lost wax technique. A die is prepared from the impression. Using inlay wax, a wax pattern is made. Pattern is then attached to sprue. The wax pattern is then attached to the crucible former. Vacuum mixed phosphate bonded investment is used to invest the wax pattern. Care should be taken to avoid air entrapment. After complete set of the investment, casting ring and crucible former are removed. The set investment is then heated in a burnout furnace. When the investment is hot, it is loaded in a centrifugal casting machine. Ceramic blocks are added as per the requirement in the crucible. Casting machine is activated and the casting procedure will get completed in couple of minutes. The casting is then retrieved carefully. The obtained restoration is trial fitted in a die. The casting that was obtained is a glass type of material. It won't be much stronger. This is because ceramics are difficult or impossible to melt. So a glass and a resinous mix is used to cast the restoration. It has to be then converted to a ceramic by a procedure called ceramic. For ceramic procedure, the glass restoration is heated at a controlled temperature in a ceramic furnace for a specified time as mentioned by the manufacturer. By this ceramic procedure, the restoration becomes much harder and stronger because during ceramic procedure, the part of the glass will be converted to a crystalline ceramic. At the end of ceramic procedure, we obtain a restoration that is monochromatic. This is because the entire restoration is made from the same colored ceramic block. So in order to create a natural appearance, coloring and staining is done and fired for a shorter time. This gives the final restoration a good aesthetic appearance which is ready to be cemented in the patient's prepared tooth. The next technique is a slip casting or a infiltrated ceramics technique. The term slip casting resembles a casting procedure, but it has no relationship with casting procedure. In this technique, a low strength core of ceramic is made and it is then infiltrated with glass to strengthen it. That is why it is also called as infiltrated ceramics. The popular term Inceram represents the slip cast ceramics. Alumina, spinel, and zirconia restorations can be made using this technique. Unlike other methods for slip casting, a dry and a porous die is made from the impression. A wet mix of ceramic powder mixed with liquid is applied on top of the die. As the die is very dry and porous, it absorbs the water from the mix and it will set. It gains strength, but it will be still weak. In order to strengthen it, it is partially sintered in a ceramic furnace. To make it extremely stronger, a molten lanthanum glass is painted on the surface of partially sintered structure. It is then heated in a ceramic furnace for extended time as recommended by the manufacturer. While doing so, the lanthanum glass will infiltrate the partially sintered ceramic by capillary action and strengthen it. On top of this coping, ceramic layering is done similar to that of the condensation technique and final restoration is obtained. For those who did not understand the mechanism, let me explain in simple terms. Ceramic powder and liquid is mixed to get a slurry consistency. This slurry mix is applied onto the surface of a dry and porous die. The die is very dry and porous so that it will absorb the water from the mix. So the mix sets harder. This mix is called as slip and the dry die is called as cast. So the name slip casting. It will retain the shape but it will still be weak. So it will be partially sintered in a heating furnace. On top of this partially sintered material, glass infiltration molten lanthanum glass is painted. Once heated, this infiltration glass will penetrate and strengthen the restoration. So thus we get the final restoration which will be much harder and stronger and it is also very aesthetic. The next technique that we are going to see is the computer aided designing and computer aided machining or manufacturing or milling. This is the current trend in the ceramic restorations. Ceramic is a very hard and a brittle restorative material. Grinding or milling it in its fully sintered state is very difficult and time consuming. So the usual procedure is to mill the restoration in a weaker stage and then heat it, that is, sintered at higher temperature to strengthen it. Green state means it is a soft ceramic which is not heated. It will be extremely easy to grind these blocks. Partially sintered blocks are harder than green state ceramics. After grinding, they have to be completely sintered. Fully sintered ceramics are the hardest, and after milling, it can be directly fixed in the patient's mouth immediately. It does not require a time-consuming sintering procedure as it is already sintered, but milling time will be more compared to that of the other two types. CAD-CAM technique is very helpful for making single-visit ceramic restorations. After completing the tooth preparation, a specialized camera is used to capture the prepared tooth. The signal is then fed to a computer from the camera. The image is opened in a CAD-CAM designing software in the computer provided by the manufacturer. In the computer software, the tooth shape, size, occlusal relationship are all designed, and this final data will be fed to the grinding or the milling unit. The milling unit has a grinding arm mounted with grinding tool which can move around in different axes to grind the restoration. The specified ceramic block is mounted in the milling unit. As per the information received from the computer, the milling unit will grind and make the restoration. If it is a fully sintered ceramic block, then it does not require sintering. If it is a green state or a partially sintered ceramic block, then sintering should be done in a ceramic furnace. After sintering, final staining and shade matching is done, and the restoration will be ready to be cemented. The sixth technique is a copy milling technique. Copy milling is a similar technique compared to CAD-CAM procedure, but it does not require the use of camera to scan the prepared tooth, and also it does not require the use of computer. Here in copy milling procedure, a die is made from the impression and a pattern is made with acrylic or special composite material using the conventional techniques. This pattern is mounted in one side of the copy milling unit. A stylus will touch and sense the shape of the pattern, and these details are provided to the milling unit, which will grind the ceramic block, creating an exact duplicate of the pattern. Once the milling is completed, similar to the CAD-CAM restoration, copy mill restoration are also sintered if needed and then shade matched. The last technique that we are going to see is machining of dry pressed powder on enlarged die. Because of the advancement of other processing methods, this technique has become obsolete, but it is a wonderful technique to make high quality ceramic restorations. All ceramic restorations will shrink in size when it is sintered. So any restoration which is made from partial or green state ceramics will be made at a bigger size to compensate for shrinkage. In this technique, a computer is used as a guide to calculate the percentage of shrinkage and to compensate the shrinkage. With the aid of the computer, a guided enlarged die is made. Dry powder of ceramic is pressed with a specialized unit under pressure onto this enlarged die. This is then machined by a unit to the required thickness and shape. This is then sintered at a high temperature for the required time. On top of this, incremental layers of ceramics is added and sintered as needed. An example of this technique is Procera all-ceram restoration. So coming to the end, these are the common methods of processing dental ceramics. Hope you understood the different techniques. Comment your opinion and suggestions. Thank you for watching.